So in this video we are going to do an example of how to determine the end behavior of a function if we're given its equation. So you'll see here that we've been tasked with finding the end behavior of this function y equals negative 3x cubed. And so to determine the end behavior, a graph is really helpful. So I'm going to use my TI-84 and graph this function and then take a look at the graph. If you don't have a graphing calculator, there are online graphing calculators available. One of my favorites is in a website called Desmos. So I'll put this here, desmos.com. But with this TI, I'm going to go ahead and come here to the y equals, and I'm going to enter negative 3x cubed. And so I've got my function now here in my y1. Let's check our window. Okay, and I've got here x going from negative 10 to 10, y's from negative 25 to 5. The scales are 5. So this looks good. We could always adjust that if we can't get enough information from the graph. So let's go look at a graph. Okay, so here we see then that this is the graph of the function y equals negative 3x cubed, and we're looking for the end behavior, which means that we're going to look at both of these ends, right? So let's take a look at the left end. And so how we describe this is we say as x approaches negative infinity. So notice how we are going to look at the left side of the graph, and our x's are getting more and more negative there, right? As x approaches negative infinity on this end of the graph, what's happening to the graph? Well, it's pointing up, isn't it? So our y values are getting bigger and bigger. And so we say that y approaches infinity, and we write it just like that. That's positive infinity. Now, if we take a look at the table, let's see if our table of values supports what our graph is stating here. See if that helps to visualize what's happening here as well. So now I'm going to go to the table, which is second table. So then I want you to notice here what's happening. So as my x's are getting smaller and smaller, so they're getting more and more negative, right? They're going from negative 20 to negative 30 to negative 40 to negative 50 to negative 60. What's happening to y? Well, y's are getting bigger and bigger, aren't they? See, starts out here from 3,000 to 24,000 to 81,000 to 192,000. So my y's are getting very large. And so that's why we say that y approaches infinity. So y is going up in value towards infinity as x gets more and more negative. So as x approaches negative infinity. So that's the end behavior of the left side of that graph, right? Let's go back and look at the graph for the end behavior of the right side. So now here, as x is getting larger, as we're going towards the right with x, so you know that on the right side of the graph, this is x getting larger. The y's are getting smaller. Do you notice how our graph is pointing downward? So our y values are going towards negative infinity. So that end behavior for this side of the graph is as x approaches positive infinity, y is going to approach negative infinity because our y values, our graph is pointing down. Okay, so again, let's check our table. Let's see what the values say. And so notice here, as I scroll down here, that as my x's are getting larger, right, they're going from 10 to 20 to 30 to 40 and so on, right? What's happening over here to the y's? Well, y started at negative 3,000, then goes to negative 24,000, then goes to negative 81,000, and now this is our scientific notation here where we have negative 1.9 times 10 to the 5th. So that's going to be like 190, negative 190,000. So definitely our y values are decreasing. They are getting smaller and smaller, more and more negative. And so we would say that the end behavior on the right side of the graph there, as x approaches infinity, the y values, the outputs, are approaching negative infinity.